said, how do I subtract vectors? Said I don't. I add the opposite. That was quite clever of us. But then we said we can break a vector up into its components. And by doing that, we can add stuff that's not at right angles to each other. Like, Jake, this example here. It says add 14 newtons due west and 24 newtons at 30 degrees south of west. Ooh, this has angles in the question. This is not going to be nice right angle SOHCAHTOA. First thing I'm going to do is I'm going to go north, east, south, almost put the south there, west. That was silly. Well, they want us to add these two vectors. Jeff, my friend, what's the first vector they gave me, magnitude and direction?
14 newtons due west.
Yump. Okay. And what's the second vector? I don't care about the magnitude yet. Read to me the direction part, please.
Southwest.
South of what?
West.
Again, south of what for a reason?
South of west.
South of what?
West.
To draw it, I'm going to do the of west first as a dotted line. And then what direction of west do I want to go?
South.
Yeah. So from here, I'm going to go which way, up or down?
Down.
That's the vector. And it's 24, so I drew it about twice as long as the 14, but not quite. See how we put that together? That's why I had him say south of what? South of what? It's the of what. That's going to be your dotted line. And then you'll go either north or southeast, the first part of that direction. 24. And what's the angle?
30 degrees.
Okay. Well, how would I add these two together? Draw them. Okay. Once you've written this down, put your pencils down for a second. Okay. You can do this. Don't write this down. You can go, okay, that's going to be 14 plus 24, where that angle right there is 30 degrees, and I guess that's the resultant. What's the problem with that triangle? Will SOHCAHTOA work? Why not? Because there's no which angle. There's no right angle. Now, there is something called the sine law and the cosine law, and you look at them in Foundations of Math 11, and some of you may be just starting to look at it. There is a way to solve that. The cos law is c squared equals a squared plus b squared minus 2ab cos c. And the sine law is sine of big A over little a equals sine of big B over little c. There's ways to solve it. And in Physics 12, I expect my kids to know the sine law and the cosine law because it's faster and because I'm a nerd. But in Physics 11, I can't. That's why I said don't write that down. Instead, what we're going to do is we're going to break the slanty part into components. We're going to say that's actually that way and that way. It says newtons, so this is a force. I'll call it Fx, and I'll call it Fy. How's that help? Well, first of all, what do you want to find first, Fx or Fy? I'm okay with the 14, the original, because that's already a nice horizontal. I'm good with that. Anthony, what do you want to find first, Fx or Fy? Doesn't matter. Fx, opposite, adjacent, or hypotenuse? What about the 24? Which trig function? You know what? If you're smart, you'll write this at the top of your page right now. If you're smart, when you're doing the homework, you'll put that at the top of the page somewhere, maybe even every time you turn the page. Trust me, it takes 1 second, cuts down on your mistakes. What was your suggestion there, buddy? I agree with you. What always goes next to the trig function, the angle, which is 30, isn't it? 30, isn't it? And that equals fx over 24. Anthony, how would I get the fx by itself? So you've guessed both. Which one? Anthony, what's the 24 doing to the fx? Adding, subtracting, multiplying, or dividing? So how will I move that 24 over? You don't say, really? So if I hear you correctly, Anthony, my friend, and I think I do, you're saying it's 24 cos 30, which is what? Let's go to three or four sig figs, because we're going to be using this to find other stuff. See, do you get 20.785? 20.78? Yeah? Okay. And in terms of a direction, I guess that's at exactly west. Yep.
Can we use the sign lock or not?
You know it? This is going to be cosine law, to be honest.
Yeah, well, we just learned it in math for this.
Are you foundations or pre-calc? So you guys are just doing it in pre-calc?
We literally just started.
Okay, I'll show you how to do that later on this lesson. The short answer is yes. However, the component method still works great if both vectors start out at angles. Here I gave you one nice vector and one slanty. If they're both slanties, I tend to go components because it's about the same amount of work as the other one, but it's easier. Can I keep going, Rob? Okay, excellent. Hey, Rob, my friend, what about Fy, opposite, adjacent, or hypotenuse? Fy is opposite? Which trig function? Sine? Mr. Dueck? Yeah, Rob? Hang on here. I'm noticing in the first example, Vy was sine. I'm noticing in the second example, Fy was sine. I'm noticing in this example, Fy is sine. Mr. Dueck, will Fy be sine always? Usually. Mr. Dueck, is there an easy way that I can remember that Fy is sine? There must be some easy way, Mr. Dueck, that I can remember that Fy is sine. I got nothing. If I was a good teacher, I'm sure I'd come up with something. I got nothing. Anthony, how would I get the Fy by itself? Multiply by 24? Double check. I think this one works out to exactly 12, right? And going back to your question, Rob, it's something of a pick-em which method's faster, cosine law or this. I'm faster on the cosine law, but that's because I kind of worked at it. I can do it all in my calculator showing no work. I got good at it in high school. This is cleaner in terms of, hey, it's Math 9. You know, you've been doing this for a while. Rob, here's my argument then. Really, this question is saying add 14 plus 12 plus 20.78. Now, I realize that's 3 vectors, but which of those are 2 nice vectors? I think I lost you. So here's what I said, Atla. Instead of going 14 plus slanty, why don't I go 14 plus its components? Right? Same, it's got to be the same question. Why is this nicer? Which 2 can I add together quite conveniently, Atla? And even if this had been east, it'd just be winner minus loser. But right now I got 14 west and 20.78 west. Really, this is the same as 34.78 to the west. 12 down. Manny, how many vectors do I have now? And are they at nice right angles to each other? Oh, Manny, I got a hankering to add these together. Have you any suggestions for how I might want to draw them? Tip to tail, you say? You'll notice, Manny, that red line that I just drew looks very similar to the red line that I drew when I showed you could use the cosine law. I think the one that I drew earlier and then erased was slanty down and to the left. Yes? So here is our force resultant. I'll call it FR for force resultant. Do the Pythagoras, please. Find theta, please. And then try doing the what of what. North of south, east of west, what of what. I'll freeze the screen. I'll do it up here. Let's see if we end up in the same spot. What I got for a magnitude. Theta. No, yeah, I think. No? Anybody else? Seeing a few of you nodding. I got 36.8 newtons, magnitude. By the way, most of these I'll give you, this one would be 3 marks because it's a slanty, but if it's a horizontal and a vertical, nice one, it'll be worth 2 marks, and it'll end up being half mark for the diagram, half mark for the trig, half mark for the magnitude, half mark for the what of what direction theta, usually. I got 36.8 newtons. I got 19 degrees south of west, which is also 81 degrees west of south, and that's what you would have got if, excuse me as I cough. Trev, that's what you would have got if you had drawn the 12 first and then the 34.78. Doesn't matter. Yep. Am I wrong?
71 degrees.
Isn't it 71 degrees? Yeah, I think that looks better to me. Thank you. Thank you, Captain Obvious. Appreciate that. 71 degrees would work much better. Forgot to carry the 1. I never make mistakes. So when do I pull out the component method? If I got slanties. Here's an application. Plane navigation. A plane's engine speed is 240 meters per second due east. There's a crosswind blowing at 125 meters per second at 40 degrees north of west. What's the plane's velocity relative to the ground? Okay. Well, for a plane question, we've said this. Whenever we're talking about an airplane in a crosswind, it's the engine velocity, and I said engine speed in the question because that's what they call it as pilots, but it is velocity. Jeff, combined with the wind's velocity, that's what gives you what the ground sees, what the people on the ground see. Okay. What do they want me to find here? Sorry? V ground, which is already by itself, because we did do one where we had to subtract here by itself. Okay, let's dolp. Oh, I've turned the page. Okay. Engine velocity, magnitude, and direction. Low. Engine velocity, VE, magnitude, and direction.
240 meters per second east.
Yoink. Wind velocity, magnitude, and direction. Oh, wait a minute. This has got an angle. Get the magnitude later. Let's get the direction first. What of what? North of what? North of what? So I'm going to draw west first. I'm going to go north of west. How long? You know what? My line's too big. 125 be about half as long as that 240. Again, I won't be fussy on scale. What angle? 40 degrees. I've drawn my slanty 40 really small, and so I'm going to redraw it over here to find the components. There's the 40, there's the 125, and I'm going to say, hey, here's the components. Yoink, yoink. And these are speeds, so I'll call them Vx and Vy. Come on. Okay, I give up. Let's just do that. There, now it's black. Vy, opposite, adjacent, or hypotenuse. Opposite, adjacent, hypotenuse. Which trig function to find Vy? Oh, look at that, it is sine again. Sine 40 equals, you okay, kiddo? Okay. Vy over 125. Vy is going to be 125 sine 40. 125, whoop, 25 sine 40. 80.35. Vx is going to be cosine. Okay. Cos 40 equals Vx over 125. You're good, Sasha. But you'd be better if you were on time. Vx is going to be 125 cos 40. $95.76. Okay. So it looks like what I really have, if I redulp this, I have 240 this way. I have 95.76 that way. Looking at my diagram, yeah. And I have pointing upwards, north, 80.35. How do I add three vectors together? I don't. I combine the two that are nice, that are in the same direction, same plane. Now, these aren't quite in the same direction. You know what, Michael? This is going to be a winner minus loser. It's going to be 240 minus 95.76. $144.2. That way. 144.2. That way. 80.35. By the way, Rob, what if they gave me two slanties? What if they gave me this one slanty and this one slanty? Component everything. Add the verticals together, either winner minus loser or winner plus winner. Add the horizontals together, and then add each of those tip to tail. Okay, so we can handle it. Rob, how would you suggest that I add these two together if I have a hankering to do so? Tip to tail, you don't say. Look at that. Who knew trig was useful? 144.2. 80.35. Looks like that's what the tower will see this plane traveling at. Northwards and eastwards. Solve that. I'll do it up here. Let's see if we get the same thing. So here is my V ground. I think that's what I called it. Is it meters per second or kilometers per hour? Meters per second. Carried the one that time. Is that right? 29 degrees north of east, 61 degrees east of north, and 165 meters per second. So in your homework today, you're going to have some slanties. They're now fair game. One slanty, component it. Two slanties, component both of them and do the verticals together and the horizontals together, and then add those together, tip to tail. Where else can we use this? Little Physics 12. Okay? Also, though, some good review. An object is initially moving at 6 meters per second due east. Check. It accelerates due south at 3 meters per second squared for 4 seconds. Find V final by using, now we've flogged this equation to death, Kyle, Vf equals Vi plus At. But now we've got some directions. Okay. Kyle, what do they want us to find here, my friend? Okay, I'm going to go Vf equals. But now, instead of numbers, I'm going to have a DALP equation. What's Vi? Magnitude and direction. plus. What's A? Direction? For how many seconds? So what do you think? What do you guys think that is? Direction. 12 south. 3 south 4 times is going to be 3 south, 3 south, 3 south, 3 south, or 12. What are we supposed to do with those vectors? The equation has a plus sign, does it not? It says VI plus AT. So, Kyle, any thoughts on how I could plus those? Tip to tail? Really? Cool. So the final velocity is going to be that. It's going to be that. Neato. Cool. Kinda. Little. Sorta. Well, time for a little Pythagoras. .4 units, meters per second, at yoink. There's my theta. Oh, opposite, adjacent. Tan again, Mr. Dueck? Well, apparently. The tangent of the mystery angle equals opposite over adjacent. Do you get 63.4 degrees? What of what? North of south, east of west? What of what? This is going to be south of east. Or at east of south. Otla, what is 90 minus 63.4 in your head, please? Not so easy, is it? Carry the one, boy. Oh, sorry. What? Sorry? 26.6. Is he right? Yeah. He is? That would be if you went the 12 first and then the 6. You'd get a different angle, but the same magnitude. Point being, Halen, actually everything I've showed you so far this year, where I've carefully drawn the vector signs, like momentum, like velocities, like displacements, they actually work in Physics 12 in 2 dimensions just fine. In fact, they'll work in first year university in 3 dimensions just fine. We just have to adjust how we calculate them. But the equations themselves are universal, still work. Still work. Last day, I gave you this sheet here called Vector Additions. So you can now do every single question on here, even some of the slanty ones. So for example, I noticed towards the end, I see in the second section where it says practice problems, hey, I see for D 8 meters, add 8 meters east and 6 meters 35 degrees north of east. Can handle that now. Components. Components. Ooh, 2 slanties. Components, components. Components, components. Going back to your question, Rob, also remember you'll have to use the sine law or the cosine law to find theta too, because you're in a slanty angle. It's doable. And if you want to, I can show you, or you can go with components. I'm fine either way. What else? I have for you a take-home quiz. And that's going to be due Thursday, because I see you in a week. Let me hand that out.